I'm really to the point. This gets a little embarrassing. I have seen some of you for years, and I honestly don't get to know names because we've got 50 minutes and we've got to do the math. So, hello. I could call you Sally and Betty and and Joe. Yeah. But I'm Carol Little. I am pre-K through 5. I make sure that we know that the kids are getting a continuous curriculum that makes sense. And we know that this math, especially today, is very different than the way you were taught. We were taught a lot of algorithms. I will tell you one story when we get closer to it about how I know how to multiply or divide, which algorithm to use. And honestly, I use a problem that I know the answer to, and then I try the 2 algorithms I know. I know one's for division, one's for multiplication. I never remember which one. So I find the algorithm that matches the problem I know, and then I solve my problem. That is not an understanding of mathematics. It's a clever strategy. It worked for a long time, but that's not what we want our kids to do. We want them understanding what this is. And that's why we are into a lot more stories and putting stuff into context, because actually that really does help us understand it better. I'm going to close this. We were freezing a minute ago. We may get warm again. I can turn the air conditioning back on. So let's take a look at this. Yeah, I didn't even give you vocabulary on this unit. We're multiplying, dividing. We don't get hung up in the words quotients, sums, products. At this point, most of the kids know them, but this really is about the mathematics. So we're going to jump in. Multiplying of fractions, we get to a bit of a fluency level, and you're going to see why. Division of fractions in 5th grade is absolutely introductory. We do not get to fluency. We do not even pretend to get to fluency in 5th grade. It's more about understanding what's going on. Division of fractions, when we ask most adults to write a story with 5 divided by 1/2, it's about 88%, they say, will actually write a multiplication story. So we're trying a lot to get past that so that kids understand what we're asking for. We're going to start off with finding a fractional part of a whole number. They get introduced to this. They may do a little bit in 3rd grade, and they may do a little bit in 4th grade, but it's more as reasoning, not actually thinking of it as multiplication. They use multiplication and all that stuff, but we're just kind of setting the stage for them to get to this point. So we're using this tape diagram. There are other models. The reality is this one works for this so often and so well that we totally accept other models that kids do, but this is the one we mostly use in class. And we'll talk about it. Modeling is a reported standard on our report card. It's probably the least understood of it, especially by parents. So we have on the report card an area that says practice standards. It then says problem solving. I could get these out. No, then it says communicating and reasoning, and then modeling. Modeling is about, can you show us a representation that shows us that you understand the problem going on? So you need a fair amount of labeling. You need some sort of representation. In elementary, it's usually a picture. They're going to hit 6th grade next year, and tables and graphs are going to become pretty important. Just due to the arithmetic that we do, they're just not particularly one of the representations we use. Every once in a while they may pop up, and usually when they do, they make so much sense, it's not something we have to have taught into. So let's just take a look at this. There are 32 students in a classroom, or in a class. That would be in California, not here. Of the class, 3/4 of the students bring their own lunches. How many students bring their lunches? So to just figure out, can we picture this story in a way that it helps us to figure out what's going on? One of the first things we know, or what do we know in this?
The number of students.
Yeah, and that's its total. Back in first grade, we learned about tape diagrams being a part whole representation. 32 is our whole. And as far as, I'm going to put students. I'm going to explain a little, or I'll show you why I put STS. By fifth grade, I totally accept abbreviations. Yours doesn't have to be mine. It's just, you're going to see in a minute how I read back this model that you can understand from the model what the question was. So we know 32 students. What else do we know?
Divided into 3/4.
1/4 maybe.
Right, so we know something about the 3/4. Are you going to hide in the back?
I might have to go back because I can't.
And I understand that, Kelly. Do you want to get there's extra pages. She works here. She may have to scoot out. She's important. So we know that 3/4. So that means I need to break this model into fourths. By fifth grade, we have talked about fractions being equal parts quite a bit. I sometimes forget to mention that to the parents. So this may not look equal, but it's close enough. We know that it's representing 4 equal parts. I'm going to go ahead and switch to colored pencils. I don't know that you need it in this section, but we know that 3/4 of them brought their lunch. What does that tell you about the last fourth? It means they didn't bring their lunch or they bought their lunch. I mean, there's a lot of ways of describing it. But we actually do have more information than just about the 3/4 that brought them. So I've broken this into 4 equal pieces. I know the total. How much is one piece worth? 1/4. So if this one is worth 8, this one is worth 8, this one is worth 8, and this one is worth 8. But my story tells me that 3 out of the 4 brought their lunch, so I know it's these 3. So how many students brought their lunch?
24.
Now, in their modeling and their communicating reasoning, one of the things that is expected is an answer statement. And this is at the point, when I'm looking at this, I can answer many different questions. I could have answered, how many didn't bring their lunch? I could answer, how many more kids brought their lunch than didn't bring their lunch? Or I can answer how many. That's why we ask for the answer statement. It makes the child, makes all of us go back and read, what is the question of this story? So the answer to this, the answer statement would be 24 students brought their lunch. Now, if we were to take this story away, I can see one thing I didn't do already. I kind of didn't label what the general story was. If I were to take it away, could I now tell you the story that was asked? I want this to be blank, I'm not sure. So looking at my model, have I given enough information and labeled it enough to be able to tell it? I would say I did okay, because there's no question mark, so I don't quite know what the question is. But I could look at that now and say, okay, there were 32 students. 3/4 of them, I can see that, brought their lunches. So 24 of them brought, 8 didn't. And because I don't have a question mark, I don't quite know what the question was. So originally, because that 8 we figured out before we did the model, I could have put a question here and said how many brought their lunch. That's what we're expecting from a model. The model retells us the story in picture form, and now I know how to solve it. I have put enough information down there that I can figure out how to solve it. This is a simple one, so sometimes it takes actually getting to a more complicated one where you can appreciate how this works for us, and maybe by the last one we'll be there. This works whether we have a story or not. So 1/6 of 54. What are we going to do with this, 1/6 of 54? Yep, we're going to put in 6 parts. What else does the question ask for? We're only asking about one of them. So I put a question mark, and I can say the entire thing equals 54. It's my habit, and I think it's most people's habit, to put this up at the top. It's not required. It would mean the same thing if it was down at the bottom. So how am I going to find that? Well, I have 1, 2, 3, 4, 5. I have 6 equal pieces. So 54 divided by 6 is? So each one equals 9. We get to the point, we don't have to absolutely label everything, that there is some acceptance that we know that they're all equal parts, so we could say 9. So 1/6 of 54 is 9. So here we have what we call the naked numbers. The other one was the story. I would like you to go ahead and try the New York Rangers problem. I'd like you to do it, and then I'd like you to talk with the people at your table to see if they solved it the same way. We have a different type of information here. So my question would be to the kids, what do you know? What detail can you add that will help you? So how many parts should I cut my diagram into? 3. I know something about 2/3 of them. They are the games they won. So we know enough about sports to know these are the games they lost. What other information do we know? 21. So if this one is 21, what does this one equal?
21.
And this one. And what we're looking for is how many total were there. So this would be 21 times 3 equals 63. And how many times did they play? I want season or hockey games. And so they won. No, they played, excuse me. 63 games. Would you turn to your partner? What other question could we ask about information that wasn't given to us but we can now answer?
How many games did they win?
Yeah. So we end up, usually with a fair number of questions we can answer. Okay, Abby spent 5/8 of her money. I'm not sure if you've noticed this when I draw things. If it's an even denominator, I always cut it in half and go from there. So we try to make our representations reasonable, but we don't get out rulers. So I know she spent 5/8. Oh, what else do we know?
She
spent 54
That's
over
five
those
weeks,
5
huh?
weeks.
Yeah, she also spent $45.
45, so.
So we know that the 5/8 equals 45. How does that help us?
We need to get find the 3/8.
So are we being asked to find the 3/8?
Oh, no.
You can divide 45 divided by 5,
Why are we dividing 45 by 5?
because that's how much you spend, and that part, there are 5 parts.
So this kind of becomes our total for the
Yes.
45. It's divided into 5 equal parts. So I'm pretty sure she spent that. And then the question is, how much did she have at first?
Well, you add the one.
The figures are 3, 5, equal to
What do these equal?
27.
They equal 27 because we have 9 times 3.
Okay, add it to the 45.
Okay. So we have 45 plus 27 equals 72. And I would put dollars. Anybody solve it a different way? Yes?
You just said 9 times 8.
Yeah, you could, now that we know what each one is worth. We know there are 8 of them. So we could also do 9 times 8. Did we get the same answer? Yeah. So there were 2 very reasonable ways to solve that. The reason we accept the multiple ways, if I immediately go to 9 times 8, when a child saw it as 5/8 plus 3/8, or 45 plus 27, that child's sitting there going, I don't know what she's talking about, and I'm wrong. They're not wrong, they just thought about it a different way. So this is once again why we keep taking those multiple strategies or those multiple ways of solving the answer. How did we get the same answer? Because those are very different numbers up here. It's important that we see where the 2 ideas match. And that's not a great way of showing you, but ultimately we had 5 parts plus 3 parts, and that equals those 8 parts. We went from talking about the individual parts to the monetary value of each of the parts. We want that discussion. We want the kids to see that these are related. It's just a different way of solving them. Okay, could you do Jakeem's making cupcakes? And I'm doing what I shouldn't. I am not solving each of these. I'm not writing the answer statement for everything just due to lack of time. And I'm going to ask you to make sure you are doing some close reading on this. And it's where the picture really helps. Okay, I know we have 30 cupcakes. What else do we know? 1/5?
Yeah.
Well, my cutting in half isn't going to work for that. So what do we know about the 1/5?
Mint.
It's mint. What else do we know?
Yeah, half of the rest is chocolate, so
Okay.
2 more.
This is the step that is the most important because it's half of the remaining or half of the rest. We look at it and that's now quite easy. Reading it the first go round and your brain goes, this is fifths, and now she's asking me to take a half. You know, you thought we just went off into this rather difficult question. Algebraically, this is a fairly tough question. With a picture, it's not. So now we have half our chocolate, and then the last 2/5, or last half of the remaining are vanilla. But I still haven't quite answered the question. How many are there?
Right, so we divide 30 by 5.
So each piece is
six.
worth 6. I know that I need the 2 times 6 equals 12 vanilla cakes. This is the problem that really shows the value. These were practice. These were what we lead up. But this is the one where the picture really makes it easy to solve. The other ones, could you do it mentally? Probably. But we want to cement that foundation because the problems do get harder. And they get even better than this, but once you start drawing it out, they're actually fairly easy. In the olden days, these would have been work backwards problems. That was one of the toughest strategies. I mean, it was the day we cringed when we knew we had to go there. And they kind of don't exist anymore because we can do this and we've had such good success. Okay, so that's fractions of whole numbers. Now we're going to go to multiplication of fractions. And I mentioned at the beginning, this is a 5th grade standard. You're going to see, we do have them draw a lot of pictures to prove it. This is a time where we hope that kids are reasoning. They really think that multiplication means getting something bigger. You do get a larger number if you're multiplying numbers that are greater than 1. If you are multiplying numbers that are less than 1, or even one of them is less than 1, it really depends on the number whether your answer is greater or smaller. So this is why I know they can figure out the algorithms so quickly, and they will. We want them to know why it's happening and understand the reasoning for it. So, we also, this is called the area model. Middle school, I would like to have a fight with my husband. They call it the generic rectangle. I think in the world of mathematics it's called the area model more. They are identical. The reason they call it a generic rectangle is because it is. You just start with this rectangle and you draw in the things that you understand, and it will work for any problem. We do ask the kids to solve it, this particular strategy, one way, just so that we can have an easier time of talking about it. And you're going to understand when I start talking about vertical and horizontal. So this story says, there is 2/4 of a chocolate bar left on the table. Jose came in from playing and ate 1/2 of it. How much of the original bar did he eat? We do ask, or I should say I do. Maybe I'm speaking for 4 teachers and I should double check. I think most of us take the amount that we have and draw it horizontally. So I'm drawing it into 4ths. And here's where your colored pencils help. I have 2/4 of that chocolate bar. Jose, my dear brother, came in and saw it and decided to eat half of it. And we mean half of what's there. So he's eating half of the half. Well, there's half of my half, but I do draw the line clear across. But if he ate half of it, he ate half of that first piece, half of that second piece. Sometimes people draw in this because it's representational, sorry, that's not quite dark, of the half. It kind of doesn't matter mathematically.
Or you could have taken just a full 1 bar. You could have taken just the full 1 bar.
Oh, I could have, yes, yeah. And again, we're starting with a simple problem, and that would have been absolutely fine. We could have drawn the line straight down here and said he just ate this, because we have 2 pieces and that's easy to see. I am going to show you this as a strategy, and you're going to see why we're developing it just this other way, because we're going to get to ones that aren't visible like that. So right now, how much did he eat? Well, he ate that piece and he ate that piece. Well, what size are they? Now this is a quarter, or, now I'm going to guess, this area is 2/8. Can you, boy, those pens, right, darker. Can you see the 2 different fractional amounts that are there? So we've been able to multiply 2/4 times 1/2, and we got 2 different answers. But by 5th grade, I guarantee you, they should know that 1/4. We've just proven once again that 1/4 equals 2/8, that it's an equivalent fraction. I would say up until about 5 years ago, if you did not reduce or simplify your fraction, we would have just marked it wrong. In the mathematics world, there's been a change of heart about that, because 2/8 is a correct answer, and there are contexts when 2/8 is the better answer. Not, right now, I can't particularly come up with one. We encourage kids to simplify, but we do not make them simplify because they are correct. However, we want that flexibility of mind in that equivalent fractions to know that those are the same answer. So we show it to them a lot, we talk to them a lot about it, but realistically, on an answer, I'm going to accept both answers. Okay, 1/2 of 1/3. This one, I'm going to do my thirds because that's what I have. And here's one where immediately taking 1/2, I don't have just a piece. I have to do something to it. So I'm asking for 1/2 of it. I get 1/2, and we talk about having the area of overlap. So if I have 1/2 of 1/3, I only get one of the pieces. And what fractional size is it?
1/6.
It's 1/6. And this is what the drawing does for you. Now, what I want to be doing is I'm going to start collecting these problems. No, I'm going to do it all at one time. It's much easier for me. So you notice the language here? I'm still saying 1/2 of 1/3. The next one is 1/3 of 3/4. I have 3/4. Visually, I could take 1/3 and it would be a 4th. Or I want to see 1/3. How much do I have? I have this area overlaps. And I have 3/12. Can you see that? Now, I also could look at this, tempted to use marker. I could see it as those 4 pieces. And how much do I have? Just this area, which equals 1/4. But again, it's an equivalent fraction. You could have solved it another way, just looking at it and taking the 1/3 piece, and we would have gotten 1/4. This strategy solves for all problems. The way that if I adjust, I've now looked at this and said, oh, I can just take one of them, doesn't work for everything. Yes?
Before you put the marker, you do 1/3 of the 3/4, but isn't that 4/12?
So wait a minute, I have 3/4. I take 1/3 of it,
Yes. It becomes
But
12.
but I'm only taking 1/3 of the 3/4. I don't get that one, because I don't have a full, I only have 3/4. Good question. So that's why I have 3/12. Yeah.
Question.
Mm-hmm.
When will you teach them to multiply the denominator and denominators?
Okay.
With the 3 over
My
5?
answer is I'm not going to teach that,
At all?
but give me 3 minutes
Mhm.
and you'll see what happens.
Okay. Yeah, because, yes, I mean, they will understand the concept, and then later on when they have.
Oh,
more-
just let me go, let me go. I promise. I was gonna start, I'll show you exactly how I develop it in
Okay,
class.
no problem.
Okay. In 3rd grade, when they started multiplication, they started 3 groups of 2 balls, 4 groups of 8 butterflies, I don't know. But we talked for this groups up. And then we slowly turned to the idea of it's actually a multiplication sentence. So that's what I'm doing here. We've been saying 1/2 of this group. That is what multiplication is. The mathematical way to write it is with a multiplication sign. But we do start off with that idea of groups. So we've moved on a couple days in math class, or a week, I don't know how long it takes. But we do get to the proper math symbols. So this is 2/3. I still in my brain read it 2/3 of 2/5. So I'm going to draw my 2/5. I'm going to take 2/3 of it. But I do need to remember, I'm looking at that 2/3 of the 2/5. That's the overlapped area. And what is my answer?
Uh, 4/50.
Yep. Because I took 2/3 of that piece and 2/3 of that piece, but it broke it into much smaller pieces, and I always have to go back to what is the unit within the whole. And that's what this model really does perfectly. Now I'm going to ask you to skip that problem. What I'd like you to do is 2/5 times 2/3. It's the exact same problem, except I've reversed the order. Commutative property, I should get the same answer. So if I draw it, my groups are thirds. I have 2 of them. And then I have 2/5. So I started with my thirds. I have 2/5 of my 2/3. Here they are. What do I get? 4. Well, I ought to. It's a good thing I do. So as I'm saying, we do ask them to draw it one way just so that we can have a better conversation in class. If they draw it the other direction, it's the commutative property. It still works. It just can make a little bit further, a complicated conversation. Okay. Can I move over to the chart paper? So as we do all this, and they do days of this, remember, this is a 6-week unit and you've been in here for 20 minutes. So please, you might be struggling with this. I will tell you that's when your brain is growing. They get a lot more practice. But I want you to see what happens as I collect this information. Oh, I probably wrote that one backwards, but we're going to survive with that. We proved that, we drew a picture that proved the first one was 2/8. We then had 1/2 of 1/3, and we got 1/6. We then did 1/3 of 3/4, and we got 3/12. 2/3 of 2/5 is 4/15, and 2/5 of 2/3 equals 4/15. So I've collected all our proof. What do you notice? Yeah. I don't have to ever tell them. There is a rule in multiplication that you multiply across the numerators and then you multiply across the denominators, or the other way around. I don't have to ever teach that. This is what we call students making their own knowledge. Now, do we line up these lessons really well so it hits them in the face? Yes. Sometimes more so than others. But as soon as we collect this, they have the proof. I mean, I have this in front of them. I took this from them. They're going to see that pattern immediately. And then I'm going to challenge them. Oh, but I just picked 5 lucky problems. Try 3 more on your own and see if it works. And I'll warn them to stay below 5 fifths as denominators because it gets horrible, which means one child will immediately go to tenths. Fine, go ahead and do it. Make it nice and big so you can actually draw them. And we will collect all their data, and we will know for sure that fluency, yeah, I don't expect them to leave 5th grade having to draw all these. I do expect them, and probably will ask them to prove it to me that one of those works. I want them to know how to prove it, and that's in this model. So, multiplication, yes, we get here. Division, we don't even attempt. It's not the standard. Division of fractions is, as I said, that's on the 6th grade teachers to develop. And you notice these were all fractions, not mixed numbers. At some point, drawing pictures does get cumbersome. Mixed numbers, I don't even think they go to mixed numbers multiplication. I think if they go to mixed numbers multiplication, it's a mixed number times a whole number, not like 1.5 times 1/2. We could get kids there that they're going to do it with pictures, or they're going to change it to 3/2 times 1/2 because they've proven it to themselves and they can figure that out on their own. That's not the area of fluency. We might play with it, but this is the strong point of the multiplication in 5th grade. And as I mentioned, each one of these fractions or numbers did get smaller because they were less than 1. Okay, and I just looked at the clock. We're going to get to division. This we're going to use more reasoning about. Again, the tape diagram, it's the model we're going to show them because it works well. 1/4 divided by 3 is not going to be very pretty. So I'm going to cut my diagram into 1/4. This is how much I have. It tells me to divide that 1/4 into 3 groups to be able to know the value. I mean, I see it, it's sitting there, but what's its value? I have to have equal groups. So I need to divide each one of those pieces by 3. Now do I know the value? Now can I name the value of that one piece? And the value of 3 in a fraction is 3/1. So dividing straight across does not work. It's a different algorithm. And 6th grade. If I were to write this in fractions,
No, it won't.
it won't work. Exactly. That's all I was saying. I mean, you can kind of see that 3 and that 4 there, but I don't even want to write this down because this is wrong. You know, it just doesn't work. So we'll talk, no, 6th grade we'll talk about that. That's why we have the pictures to deal with it right now.
Okay.
So 1/3 divided by 2. Go ahead and try it. Dividing it into 2 parts.
So, quick question, I know. So for them, without the tape diagram, there is no way they can find out the answer. So far.
So far. We're going to get them to understand how to divide a unit fraction. And then if you have more of them, then you multiply it by how many more, and that becomes that, I don't even know it. There's a terrible rhyme, something about, yours is not to reason why, just invert and multiply. This is the one I never knew. Was that multiplication or was that division? We don't teach that anymore. We teach them how to understand how to divide a unit fraction, and then we can multiply it. So if this is, I heard the answer, 1/6. Because I divided this one in half, I have to get equal parts, so I get 1/6. What would my answer be if I had 2/3 divided by 2? Using this piece of information. Yeah, so now I can use what I know about a unit fraction. I'm not even sure that's quite right, because divided into 2, yeah. It's, the picture doesn't work the same. It really should have been 2/3.
Yeah, it is the same.
It's gonna be
because you'll
there.
get
Yeah,
2/3 and you divide it by 2, then it will take a whole 1/3 there.
Yeah.
Which is still the same.
okay. Sybil has 1/2 of a pizza left over. She wants to share the leftover pizza with 3 of her friends. What fraction of the original pizza will Sybil and her 3 friends each receive? I want to highlight, of the original pizza makes a difference to your answer. Half.
Should divide by 4 because it's Sybil and.
Oh, thank you, Sybil and, see, there you go. Close reading, it is by 4. I just pulled the classic mistake that kids do. So how much of the original pizza did they get?
We divided by 3.
I changed it, no, we divided by 4 because it's 3 friends and Sybil.
1/8.
And, oh,
Yes, thank you, that's what I did at first too,
like 4 people there
4 people.
are sharing.
So they get 1/8 of the original pizza, correct?
Yeah.
How much pizza did they get of what was left?
1/4.
Yeah, so that's why the questions do make a difference, and that we're pretty careful about our language. In this unit, they're practically always going back to the original size of whatever their whole was. So, strangely enough, these seem to make more sense than when we go to 4 divided by 1/2. Nope, you've still got a question, go.
No, here it said each one will get 1/4 or 1/8.
No, they'll get 1/8. I asked a separate question that's
Okay.
not on the paper.
Sorry.
Just wanting you to know that you can answer and ask different questions about this one story.
Okay.
Of the original pizza, it's definitely 1/8. Okay. Now, just like I said, multiplying does not always mean your answer gets bigger. Division does not always mean your answer gets smaller. 4 divided by 1/2 is asking, how many groups of 1/2 do I have in 4? And to me, as soon as I understand how to put this into language, I know how to solve it. But I have to be able to interpret that equation. So, I've even written it down. How many halves are in 4? Oh, well, I need to find the halves. How many do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8. So 4 divided by 1/2 is 8. And I want to say not 2. That was almost, you got 2, you were multiplying. I can always take it back to hamburger. I had kids. If I had 4 pounds of hamburger, how many half-pounders could I make? In context, it's a lot, for me at least, and for most people, it's a lot easier to understand than the numbers. So this idea that word problems are so much harder is mostly because we didn't give kids the tools to solve them. Often they make the understanding easier. Okay, 5 divided by 1/3. What's the question it's asking? How many groups of 1/3 are there in 5?
15.
Mm-hmm. And this is about how far we take division. I could ask how many 5 2/3 divided by 1/3. It would just be 2 more. I mean, it can be mixed numbers, but we are drawing them to figure them out. I'm going to take you to the last page, which is really, well, one, there's a word problem. I'm not going to have you do it because I'm looking at the time. Your kids are going to talk or be exposed to that fractions are a type of division. If you look at it in pure mathematics, it is. It makes a lot of sense with the first example I give you. If I have 6 halves, if the context is right, I can tell you that's 6 divided by 2, or into 2 parts. So if I have 6 and I divide it into 2 parts, what is the value of 1 part? 3. It's nice and clean when I set up certain numbers. It's not as clean when we get to other numbers. But this is really a mathematical point to explain that it's division. And it becomes a bit circular that you're proving 3/4 equals 3/4. But it is giving you the reasoning as fractions as a division. So 1/4 is 1 divided by 4. What is the value of this piece? This is where I say it's a bit cyclical. Now, when we get into other numbers, it's not as pretty. So if I take this as 3 divided by 4, I don't have, right now, I do not have an easy way to put that into 4 parts. So I'm going to use what I was given. I'm going to take 1 part and divide it into 4ths, and divide it into 4ths, and divide it into 4ths. How many pieces do I have now? 12. But I want to divide it into 4 pieces. No, I'm trying to keep my language straight. Yeah, let's say pieces. So 12 divided by 4 equals 3. So this is going to become 1 piece, 1 piece, 1 piece. Do I now have 4 pieces? I have 1, 2, 3. I did something wrong. 1, 2, 3. Sorry, my line should be there. And 4. And I've just proven to you that 3 divided by 4 equals 3/4. This is not a technicality. It's a rule of math that this works. It also starts showing how common denominators come about and how you can find them. It's not a big part, but I just wanted to show it to you. If you walk away with this still being hazy, try another one. I'm looking at the clock. It's 9:01, so let's do 2/3. If I have 2 divided by 3, it's not a pretty one. I'm going to use what I've been given, break them into thirds. I now have 6 pieces, 6 smaller parts, but I only want 3. I now have 3. What is their value? 2/3. So this is really just a math. I mean, it's interesting to some of you. It's a very small part of it, but it's funny. It makes more sense in, we're not supposed to call them improper fractions anymore, but they haven't given me a new name. So the 6/2 tends to make more sense to us, but it does work each time. Yes?
If I compare number 2, no, problem number 2 is number 3. So problem number 2, they gave me a tape, I divided it into 4s because that's the denominator, right? Because we're dividing by 4.
We're now looking at this as a division problem.
Okay.
We're dividing it into 4 because that's
Hold
what we've
on.
been asked to do.
Yeah, but for the following one, we're dividing 3 by 4.
Mhm.
So why I didn't have 4 and then I divide them into 3s? You know what I mean?
I didn't start with 4 here, I started with 1.
Yeah, I think what is confusing me that we have teacher paired tape in the number 3 and number 4, problem number 3 and problem number 4. That's what it is.
Yeah.
Okay, I see what
So
you're
help
saying.
me understand. Let me
Because they
see.
put the tape on 2 3 boxes.
Because that's a 1 and 4, so that's 1
Because we don't think of it as 3/4.
It's a 1 whole.
Think of it as 3.
Okay.
So I have 3.
Yeah.
So yeah, this is interesting because I'm no longer thinking of it as fractional parts. I'm thinking of it as a division problem. So I have 3 of them, but I want to turn them into 4. But I'm not enlarging it, I guess I can say.
Okay, I got it.
So each piece is going to be 2/3, 3/4. Yeah.
Okay. So they have
So-
3 pieces, they want to divide it by 4.
Yeah.
Okay, thank you.
Yeah. Okay, 2 minutes too long. That's really close for me. Thank you for coming. I don't know how many of you care, but happy Valentine's Day. Again, this is a major unit in 5th grade. Your kids are going to take some time. Please do not go home and go through this with your kids all at once. I do want to show you the last page. These are our extension and our, well, a few things. Math Playground, if your child is whizzing through this and you want to give them other things to do, Math Playground, their logic things are brilliant. Logic is a part of mathematics that we don't really delve into much in elementary school, but it's a great way to challenge kids. The other ones, bedtime math is great. Math Cats, I loved it last year, not so much this year. Yeah, these are just puzzles you could do. Dreambox, excellent, excellent reviews. It is a program that kids can just work through math on their own. It costs, it might be like $10 a month or something, I don't know. I don't remember anymore. It is excellent, it is not, it's excellent. It's not particularly aligned. You can't go in there and say, oh, I want to do multiplication of fractions. It's something a child would work through on their own, and it's very intuitive. So a lot of kids, I mean, I want kids to know they're doing math because I want them to feel good about it, not being sneaky. It's a video arcade sort of thing. It lays wonderful foundations for mathematics. It's just, it's pricey. I think anything over $1.99 on the computer is pricey. I could lose $70 in a month in my pockets in the washing machine and be okay, but for some reason paying it for a computer program, I don't know. Code.org is obviously for coding. Again, coding is a form of math, not particularly what we think of it as computer science. Computer science is based in math. Your kids all have Google accounts that they can go to. Some of them have already finished the Minecraft game, but there's a lot of others on there. Great stuff. Still limit your kids to the amount of time they're on their screen, but this is a great place to be. Common Sense Media. We want everybody using this. This is for videos, this is for books, this is for video games. They'll tell you about violence, they'll tell you about advertising. I've learned something horrible about advertising on the web and found out my daughter's company is responsible for it. So they give you a good idea. You should keep this one bookmarked on your computer for the rest of your children's time at school, especially about books. I know we have a lot of strong readers. I still don't think it's right for a 5th grade girl to be reading Little Women. They have no understanding of falling in love. So yeah, I get it that they get the words. I get it that there's nothing bad in it. I just don't think it's a good choice of books when there are so many good books out there at the 5th grade level. That's the type of things they'll tell you there. Lastly, today we used a lot of multiplication facts. Your kids are supposed to know them by the end of 3rd grade. We know a lot don't. Oh, I did mean to bring a multiplication chart. On a multiplication chart where you have the tens grids and it's the 1, 2, 3, 1, 2, 3. I will tell you, down here, the 7 times 8, 6 times 7, 8 times 8, that is the area most kids don't know. Most of them know the vast majority of these. And they have a few that they get tripped up on. That is okay. But if they don't know 3 times 5, they need to start playing games. It is okay to use a multiplication table, because what I would also say by now, if your child really doesn't know 3 times 5, they probably have some sort of processing memory slowdown or glitch, because we've done 3 times 5 since 2nd grade. They've been exposed. It is not a lack of trying. It is not a lack of intelligence. It could be a lack of being able to retain it in the brain, and we've got to give those kids a different strategy. However, there's a lot of them that could just use practice. This fact games, whatever, this is a page of 5 or 6 games for kids to play that are fun. 10 minutes a day, not a full hour on the weekend. The brain likes repeated things over time. 10 minutes a day for a couple weeks, your kids are going to know most of their facts. And again, I always have to stop and think about 8 times 8. There is no harm in that. We call them the bugaboos. And they're different for each one of us. But they really need to know most of them easily, so that as they're doing this fraction work, that's not what's stumping them.
Are these the Khan Academy?
These are straight math facts. There's this great one with marbles that you shoot. It's really addicting.
Fifth grade, they should go to the.
They should know their math facts. If they don't know their math facts, they should know.
I'm saying math in general for the units. Do they go to Khan Academy now?
If their teacher assigns it,
Oh.
not necessarily. Khan Academy does align with the way we teach. We don't need to be doing 56 problems of the same thing over and over again. That's why we left IXL. Khan Academy, the drawback is it does 5 or 6 problems. There are kids that 7 or 8 might be better for, but that's why we're using Khan Academy. It may or may not be assigned. It may depend on your teacher a little bit, and it may depend on your particular child. We do not necessarily give 100% of the same homework to 100% of the kids, because you may be flying through this and the homework may be a waste of time, and I may need that little bit of help and getting immediate answers so I don't do a whole page wrong and come back having practiced absolutely something wrong. And that's the value and the beauty of Khan Academy or a web-based things. You get an immediate response to right or wrong. I'm going to say I am more than welcome to stay and answer questions. If you need to get going, please do. Thank you for coming.